nowadays we are working on. So students of this class are eagerly participating in it, and some are not participating, so no need to worry about it. Okay, only one thing: without hard working, no one will gain anything. The only principle behind a success is hard work. Okay, a simple example is myself to you. I am the example for that. I started my teaching career 26 years ago. So now 26 years over, if this October comes, 26 years are finishing. 27th year is starting. Compared to last year, this year, the works, the practices, the loads are more. Compared to this year, if you take coming year, the present grade 10 class, their work will be much more improved. Day and night, I sit and prepare those materials. Why? Only one thing: hard work only brings success. Otherwise, I also can keep cool now, doing the classes, fully resting. Okay? Even you didn't ask, sir, send me papers. We will do. Please send me papers. You didn't ask. It is me sending those papers. Marking schemes. No one of you asked to send papers. So thing it is, success is there only for hard workers. Okay? If you are hard working, success will come runningly near to you. Without hard working, okay, even Allah subhanahu wa ta'ala will not give anything to you. He didn't give anything to Rasulullah without hard work. To his mightiest prophet, mightiest messenger, he didn't give things just like that. His mightiest messenger. Then will Allah subhanahu wa ta'ala give anything just like that to you and me? Me, never. That is one thing I want to convey you. Second, it is today in the group I have sent a message. In the message I have pointed you, I'm going to form a new group because the older group has children, the students who are not in the class also in the older groups, they are there. So it is better to renew those groups. If we renew only, the group will be fresh. Okay, so due to that reason, those who have completed June payment, now July is going on, June payment completed ones and July newly joined ones will be joined to the new group. I have already created that group. Okay, at the moment I have, no, it's not that meaning. At the moment, there's only one child I have joined to it. Using her name, I created the group. No other ones are yet added. By today night, inshallah, we will be adding it. After adding it, I will send you a message in that group. or after adding it, you will get a message to leave the older group. Okay, in the new group, that message will come. Leave the older group. Then you have to leave the older group. After all the potential children leave the group, that group will be completely dissolved. Then the new group will be in action. Okay, inshallah, it will be done within this coming class will be on that format. Okay, in the new group only link will come. Right. Anyway, the broadcast is going on. Anyone who is not working, I will silently, I will not shout. I will not tell, I will not ask anyone, hey, didn't you do the work? No, those things will be there. I will silently remove that person and stay. Okay? You have to do the works on time. Punctuality. Okay? Punctuality is one of the key factors. Right. Anyway, I'm not highly stick to the 8 o'clock. When you send it 9 o'clock also, I am accepting it. 10 o'clock also, I am accepting it. But if you send it the next day, very sorry. Okay. So, I think we have completed the unit number 7, correct?
Yes, sir.
Right. And today we are starting unit number 8. Comparatively, this is a Is there any portion still pending in the unit number 7?
No,
Not.
sir.
Is there anything pending?
No, sir.
No. Right. So, what is the heading in the unit number 8?
Heat changes associated with chemical reaction.
Right. Now, we will start the lesson in this manner. When a paper or a wood is burning, we all have experience. The area become hot, correct?
Yes, sir.
From the burning place, heat is coming out. From the burning place, heat is coming out. What we feel is hot. Burning or combustion, we can call it burning, we can call it combustion, is a chemical reaction. Burning is a, what is it? Chemical reaction. When that chemical reaction takes place, heat is coming out, correct? Heat is coming out of that place. That's what they say here. What is happening? What is happening? Evolution of heat. Heat is coming out. Any chemical reaction in it, heat comes out. Heat comes out is called exothermic reaction. Okay, what kind of reaction?
Exothermic reaction.
Exothermic reaction. Exo mean out. Therm mean heat. So exothermic mean
Out heat.
out heat. Tell the other way. Tell the other way. Heat out
Heat out.
reactions. Understood?
Yes, sir.
Heat is coming out. Heat is coming out. That's why we say it is exothermic. So the simple, very well known example for exothermic reaction is combustion. Anything burning, heat is coming out. Any burning, any combustion is what kind of reaction? Exothermic reaction. Now, did you understand the first line clearly?
Yes, sir.
Yes.
Yes.
Now, in the exothermic reaction, okay, now remember, in every material, in every substance, there is energy. If you take our body has energy. Inside a stone, there is energy. Inside a paper, there is energy. In water, there is energy. Every matter contains
Energy.
Energy.
and that energy is called internal energy. What kind of energy?
Internal energy.
Internal energy. Right? Now, in this reactant, there's a reactant. You know reactant in chemistry, no? Correct?
Yes, sir.
In this reactant, say there are 1000 joules of internal energy. Now the reactant is turning to product. In the product, the internal energy is how many joule?
800 joules.
800 joule. Less than the reactant or more than the reactant?
Less
Less
than the
than.
Less than the reactant. Then what happens is, now reactant is turning to product, no? Reactant is turning to, what is it? Product. So, the remaining 200 joule will come out in the form of
Heat.
heat. Understood?
Yes, sir.
Yes, sir.
Can everyone understand it?
Yes, sir.
Yes,
Right?
sir.
You are having this much. When it turns to a product, it is the product carries one portion, rest is going to the
Heat.
heat. Understood?
Yes,
Yes,
sir.
Now, if you want to little more understand it, I will tell a small point. You know this man. Okay. Do you know this man?
Yes, sir.
Yes. The superstar of Indian cinema. Okay. He was making a film. He was asking the director how much money wanted. Director says, okay, 5 crores wanted. 5 crores. 5, what is it? Crores wanted. Then Rajinikanth was giving the 5 crores to the director. What the director did is, director completed the film in how many crores? Director
4.5.
completed the film in
4.5 crores.
2.5 crores. Then director was telling, Rajini sir, another 50 lakhs money remaining. Then Rajinikanth told, give that 50 lakhs, distribute among the workers of this unit. I don't want it. Understood? So 0.5 crores, he told, is not coming in the product. It is not in part of film. You give to the others. Just help the others. Finish it. Understood?
Yes,
So
sir.
he gave 5 crores. In the film, how many crores are there?
4.5.
4.5 crores.
Are there. Another 0.5 crores is extra. That extra 5 crores are given out. Go. Enjoy. Understood?
Yes, sir. Yes, sir.
Like that, reactant has 1000 joule. When product is coming, product can hold only 800 joule. Then 200 joule given out. In what form?
Heat.
The 200 joule given out in what form?
Heat.
Form.
Heat form. So that place will be feeling hot. Understood?
Yes, sir.
Right. So in that place, what will happen to the temperature? In that place, what will happen to the temperature? Becoming hot now? Will the temperature increase? Will the temperature decrease?
Increase, sir.
Tell me, what will happen to the
Increase.
temperature?
It
Becoming
will
hot
increase.
now? Huh?
It
Temperature
will
will
increase.
temperature will increase. Understood?
Yes, sir.
Yes. Temperature will, what is it?
Increase. Yes, sir.
Increase. Good. And finally, to point a reaction is exothermic. Okay. The heat change, when they are writing heat change, they will write, now say, minus 57 kilojoule. This way they write. Now, just an example. Just an, what is it? Example, one person is writing the heat change equal to minus 57 kilojoules. Okay. Point it is, this minus indicates it is, what is it?
Exothermic.
Exothermic. From the minus, you should be able to identify he is meaning it is exothermic, 57 kilojoule released out, given out, lost out. So for that minus, there is a meaning. Understood?
Yes, sir.
Please mark this down.
Okay, sir. Done, sir.
Have everyone completed it?
Done, sir.
Have everyone completed it?
Yes, sir.
Good. Good. So, passing this, we are coming to the next one. What is the heading here?
Enthalpy diagram of
Enthalpy diagram.
So,
Remember, this is actually an energy diagram. Okay, enthalpy is also okay the word, but in exam paper mostly they will tell you what kind of diagram it is.
energy diagram.
Energy diagram.
energy diagram.
Calling its enthalpy diagram. For that energy, they are using a word enthalpy, but that is not a bigger thing. It's really an energy diagram. In the O-level paper, they are going to ask you energy diagram. So if you take this energy diagram, okay, reactants are marked in the upper level, correct?
Yes, sir.
Why reactants are marked in the upper level? Because reactants have more energy than the products. Understood?
Yes, sir.
Why reactants are marked in the upper level?
They have more energy than products.
I mean,
Energy product.
Reactants have more
reactants
energy
have more energy than the
product.
And
products.
products.
Correct? This arrow shows you that reactants are turning to
Products.
products. Correct?
Yes, sir.
When the reactants are turning to products, heat is coming out. Correct?
Yes.
Yes, sir.
Right. So, what is this energy released out?
Heat.
Heat. Okay. Why reactants are above?
Reactants have more
Reactants
energy than the
have more energy than the
Products.
products.
products. Mark the 2 points there.
Done, sir.
Have you completed it, everyone?
No, sir.
Hmm. Is it over?
Yes, sir.
Yes, sir.
Right. Now, according to the syllabus, there are 5 types of exothermic reactions. How many?
5.
5. One, it is any metal reacting
Five
with any acid. Any metal, if it is reacting with any acid, it will be confirmedly what kind of reaction? Exothermic reaction. Now
Exothermic.
here they are showing magnesium reacting with hydrochloric acid. And a simple request at you, a simple request. When you are sending your worked papers to me, send it as a PDF file. Some people send photos, tokku. Phew. it is filling the inbox. Very difficult to manage. See, there's one sending. Dokku, 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 dokku. So when you are sending, send as a single PDF. Right. Second, if you take bases and dissolve them in water, that bases dissolving in water is also exothermic. Here see, who is the first example?
Dissolution of sodium hydroxide in water.
In this one, which one is the base?
Sodium hydroxide.
Sodium hydroxide. Correct?
Yes, sir.
Right. Second one, who is the example?
Dissolution of quicklime.
Dissolution of quicklime in water. In that one, which one is the base?
Quicklime.
Quicklime. Understood?
Yes, sir.
Yes, sir.
So any base, it can be sodium hydroxide, it can be potassium hydroxide, it can be calcium hydroxide, it can be magnesium hydroxide. Okay, if it is dissolving in water, in that place, lots of heat will come. Third one.
Reactions of acids with bases.
Acid-base reactions. Another name for acid-base reaction is
Neutralization.
neutralization reactions. Acids, when they react with bases, that place will become hot. And the fourth one,
Any combustion.
any combustion. And finally, cellular respiration. It is a biological exothermic reaction. It is the reason why our body is hot. Our body is hot, right? Right? Our body is hot because of cellular
Respiration.
respiration. Okay? Our body, now if you have seen a dead person, have you touched the body of a dead person? Some relative?
Yes, sir.
Yes.
Yes.
What will you feel in that body?
Coldness.
Cold body. Okay, why? Because in that body, cellular respiration doesn't take place. Clear?
Yes, sir.
Okay, he is dead mean or she is dead mean, cellular respiration has stopped. Understood?
Yes, sir.
So are you clear? These 5 exothermic reactions.
Yes, sir.
Metal
Yes, sir.
acid reactions are exothermic. Bases dissolving in water are exothermic. Acid-base reactions are exothermic. Any combustion is exothermic. And finally, cellular respiration is also, what is it?
Exothermic.
Exothermic. Clear? Right. So, I have completed the exothermic reaction. Now, on the next page, I am going to discuss about the endothermic reaction. If these things are clear only, understanding endothermic reaction is easy for you. Understood?
Yes, sir.
Right? Because endothermic reaction, normally we don't experience in our life. Okay? Endothermic reaction is totally opposite. Totally opposite. Everything is opposite. In exothermic reaction, heat is coming out or going in?
Coming out.
Coming out. Their heat will go
In.
in. Here, in exothermic reaction, okay, if you compare energy, reactants and products, who have more energy?
Reactants.
They are
Products.
products. Understood?
Yes, sir.
Here, temperature increases. They are decreases. Here we feel hot. They are
Cold.
cold. Understood?
Yes, sir.
Here in the energy diagram, reactants are written above, products are written below. They are
Products are written above.
products are written above,
Reactants are
reactants are written below. The arrow will be upward or downward?
Upward.
Upward. Understood?
Yes, sir.
Right. So exothermic energy changes are marked with negative symbol. They are
Positive.
positive symbol. Completely opposite. Everything opposite. That is what kind of reaction?
Endothermic reaction.
Endothermic reaction. See, heat is absorbed. Correct?
Yes, sir.
Products have more energy than the
Reactants.
reactants. Temperature declines. Feeling cold. Symbol
Positive.
positive symbol. Products, reactants. If you compare, you can see the energy diagram. Correct?
Yes, sir.
Yes, sir.
What are the types of endothermic reaction? One, it is dissolving ammonium chloride. What is it? What is that salt?
Ammonium chloride.
Ammonium chloride. Ammonium chloride salt. If you dissolve in water, you will feel that coldness. Clear?
Yes, sir.
Okay, you will feel like you touch ice. If you touch ice, you will get a feel. No, that feel will come after dissolving ammonium chloride in water. If you touch the beaker outside, you will feel it is what kind of feeling? Hot, cool, chill. What kind of feeling?
Chill.
Chill feeling will be there. Similarly, any carbonate, any bicarbonate, if it reacts with an acid, those reactions are what kind of reactions?
Endothermic reaction.
In this reaction, who is the carbonate?
Sodium carbonate.
Sodium carbonate. It is reacting with which acid?
Hydrochloric acid.
Hydrochloric acid. Correct? In the next reaction, Who is this?
Sodium bicarbonate.
Sodium bicarbonate. So it can be a carbonate, it can be a bicarbonate. Never mind whether it is sodium or potassium or calcium or magnesium or copper or zinc or, that is not a matter. Understood? Sodium carbonate, potassium carbonate, calcium carbonate, magnesium carbonate, lead carbonate, zinc carbonate, copper carbonate. Any carbonate, okay, but should be carbonate. Understood?
Yes, sir.
Yes.
So, similarly, thermal decomposition. You studied many thermal decomposition in your grade 10. Now it is time to bring all those memories back. Okay. Recently, I gave you unit 19 revision material. Can you remember?
Yes, sir.
Like that. Okay, I have a plan on that unit number 16 of grade 10, going for a complete revision material, inshallah. So any thermal decomposition, potassium nitrate breaking to potassium nitrite and oxygen, potassium chlorate breaking to potassium chloride and oxygen. Any thermal decomposition, not only this is also considered. Any thermal decomposition reaction mean it is definitely endothermic. And finally, photosynthesis. Photosynthesis is a biological endothermic reaction. So see, biological exothermic reaction. Who it is?
Cellular respiration.
Biological endothermic reaction.
Photosynthesis.
Photosynthesis. In exam paper, quickly it can confuse you. If you are not in good practice, say you are not in good practice, in that time, it can simply confuse you. So you should be very careful. Right. Now, coming for a heading. What is the heading?
Calculating.
Calculating
Yes.
heat changes. There is an equation given to you. Q, this is the way we read it. Q equals to MC theta. How do you read it?
Q equals
Q
MC.
equals to MC theta. This theta is the amount of heat, okay, amount of heat absorbed or
Released.
Released. Amount of heat
Absorbed or released.
absorbed or released. How much heat is coming out? Now we told no. This much 200 joule heat is coming out. How do we measure? To measure the amount of heat. அம்னா நசார் மைக் ஆன் பண்ணாதீங்க, உங்களோட நெட்வொர்க் சரியான வீக்கா இருக்கு, அது வந்து கிளாஸை டிஸ்டர்ப் பண்ணுது. அம்னா நசார் மைக் ஆஃப் பண்ணி வைங்க, நீங்க பேசுறதும் கேட்க மாட்டேங்குது, அது விட்டு விட்டு பிரேக் ஆகி வரதால கிளாஸை டிஸ்டர்ப் பண்ணுது. So Q is amount of heat absorbed or amount of heat released. M is mass. C is specific heat capacity. Theta is the temperature change. How to calculate the temperature change? Maximum temperature minus initial temperature. That's how we measure it. Maximum temperature minus initial temperature. So please mark it down. Amount of heat absorbed or released.
Done, sir.
Completed?
Yes, sir.
Right.
No, sir. 1 minute, sir.
Actually, this formula comes to you in the unit number 9. In the unit number 9 only, this formula primarily coming. But for this section, it is very important. That's why I am taking it in the hands at the moment. Have you completed it?
Yes,
Yes,
sir.
sir.
Yes. Now, we are going to apply this. Look at the first question. In the first question, we are going to calculate the amount of heat required to raise the temperature of 3 kilogram of water from 30 degrees Celsius to 100 degree Celsius. Okay. Now tell me, what is the M value of it?
3 kg.
3 kg. Correct. What is the C value of it? Specific heat
4,200.
capacity. C value 4,200. Read it. Joule kilogram to the power of -1. Kelvin to the power of -1. Okay. And theta. Theta 30 to 100. From 30, it is going to 100. Then what is the difference coming?
70 degrees Celsius.
I can't type theta. So theta equal to how much?
70
70
degrees Celsius.
degree Celsius. Agree?
Yes, sir.
By substituting, can you find out the Q value?
Okay, sir.
You find it and send me in the Zoom chat. Okay. Find it and send it to me in the Zoom chat. Completed?
Yes, sir.
Right. Can you give a try to do the second one?
Okay, sir.
Those who have completed the first one, give a try to do the second one. Remember, water has specific capacity, is a fixed value. If they repeat again water, you can use it what is given above. Here.
Done. Sir. Done, sir.
Done, sir.
Done, sir.
Done, sir.
Done, sir.
Done, sir.
Completed?
Yes, sir.
Right. So, what about the third one? So, in both first and second, you will be getting the same answer, right?
Yes, sir.
Yes.
Same answer. That is really accidental. Both of them gave you, what is it? Similar answers. Actually, it's an unexpected one. Okay. Coming to the third one. What is the heat required? Here, how much the mass?
30 kilogram.
Whose mass it is?
Gold.
Gold. If you are using gold's mass, then you have to use gold's specific heat capacity. Understood?
Yes, sir.
If you are using copper, then you have to use copper's
Copper.
specific heat capacity. So according to the material, you have to decide the specific heat capacity. In exam paper, they will give you the specific heat capacity. Clear?
Yes.
In exam paper, they will give you the specific heat capacity. So now you complete the third one. Yeah.
Done, sir.
Done, sir.
We don't want any dancer here. Send your answer in the Zoom chat. It is only Imanka has sent her answer for the third one. Other people have told dancer. Dancer is not the answer, no? So the third one, the correct answer, 117,000 joules. This is the correct answer, 117,000 joules. Okay, now try the fourth one. Remember, here the mass is given in what unit?
Gram.
Grams.
Grams.
The mass is given in what unit?
Grams.
Grams.
Grams. The mass is given in grams. You can't use it in grams. You have to convert it to kilograms. Q is equal to mc theta will function only with kilogram units. So to that reason, you have to use it in the kilograms, not in grams. So up to the answers I have received, okay, one set of children, they have used it in grams. Okay, straightly using 40 into. No. 40 gram. You have to convert it to kilogram. How to convert it to kilogram?
Divide by 1,000.
Divide by 1,000.
By dividing it by?
1,000.
By dividing it by how much?
1000.
1000 dividing by 1000. So how is the values coming? How are the values coming? Q equal to M value. M value how much?
40 divided by
40
1000.
divided by 1000. That is 0.04. Understood?
Yes, sir.
0.04. Copper. What is the specific heat capacity of copper?
400.
400. Multiplication. What is the theta value?
60 degrees Celsius.
60 degrees Celsius. 60. 20 to 80 means 60. Now apply and get the Q value. Okay. Now you can apply and get the Q value. The Q value will be 960 joules. Okay. If you don't know to multiply decimal, if you don't know to do multiplication, we are not responsible to teach you the multiplication part. Okay. Some jokey answers have come. Some answers are very jokey. Okay, 164,000 has come. Okay, nice multiplication, 64,000. Okay, jokey multiplications there. So I am not here to teach you. Okay, another 320,000 one has come. Okay, very nice multiplications. Okay, again telling you, I am not here to teach you maths. Okay, how to multiply decimal. That is not my business here. Okay, I am teaching you science. If you multiply, if this answer comes, how to multiply, that is up to you. Right. Coming to the fifth one. If you take the fifth one, calculate the amount of heat required to raise the temperature of 300 gram water from 28 degrees Celsius to the boiling point. So boiling point of water, how much?
100 degrees Celsius.
100 degrees. So without telling 100 degrees Celsius, they are telling you boiling point. If they tell boiling point of, okay, if they tell 100 degrees Celsius, both are same. Here also, mass is given in which unit?
Grams.
Grams. So here also, you have to convert it to
Kilogram.
kilograms, dividing it by
1000.
1000. So you do it, get the answer and send it in the Zoom chat. Romana Naushad, check your answer. Romana Naushad, what is the specific heat capacity of water, Romana Naushad? Romana Naushad, what is the specific capacity of water?
300 grams.
Specific
20.
heat capacity of water.
100.
Specific heat capacity of water. Amna Nazar, what is the specific heat capacity of water?
4,200.
4,200. Amna Nazar, what is the mass?
0.3.
0.3 kilogram. What is the theta value?
28 degrees Celsius.
28 degrees Celsius, water is going from 28 to 100. Water is going from 28 to 100.
Sorry.
Is the theta coming to you 28 degrees Celsius, Amna Nazar?
72, sir.
Eh? Same mistake. Fawaz, same mistake. Romana Naushad, what is the specific capacity of water?
4,200.
4,200. Are you clear? Are you
Yes,
clear to apply this equation?
Yes,
yes,
sir.
sir.
Right. So actually, as I told you, this equation will again come to you in the unit number 9. There you will be practicing more questions. Here, the purpose is we are going to learn an experiment. Okay. We are going to mix. We are going to mix some amount of hydrochloric acid and some amount of, what is it? Sodium
Sodium
hydroxide. When you mix them, heat will come out. When you mix them, heat will come out. Why? Why do you say so? When you mix sodium hydroxide and hydrochloric acid, heat will come out. Do you agree with it?
Yes, sir.
Why?
Acid-base reaction.
Acid-base reaction. Taking some acid taking some hydrochloric acid, taking some sodium hydroxide. We are mixing them. We are, what is it?
Mixing.
Mixing them. Heat will come out or not?
Adan, sir.
Will
Heat
come
will
out.
come out or not?
Yes.
Heat will come out or not?
It will come, sir.
It will come. That heat we are going to find out. Let the Adan finish. Okay, so here I am going to share a video with you. In this video, you can notice the same experiment. What is the heading written here?
Measuring the temperature change of the neutralization reaction between dilute hydrochloric acid and dilute sodium hydroxide solution.
So here they are telling that we are measuring the temperature change. Temperature change mean we are measuring the theta. Understood? Temperature change mean what are you measuring?
Theta.
Theta. Theta is the temperature change. How much temperature is changing? 30 to 50. From 30, if it goes to 50, what is the temperature change? From 30 degrees Celsius, if an object goes to 50 degrees Celsius, what is the temperature change?
35 degrees Celsius.
30 to 50.
20 degrees.
20 degrees Celsius.
Neutralization reaction.
So here he has dilute sodium hydroxide, dilute hydrochloric acid. This is a thermometer and this is the polystyrene cup. Which cup? Which cup it is?
Polystyrene cup.
Polystyrene cup. So let's see. Now here can you see a measuring cylinder?
Yes, sir.
Yes.
Yes.
How many measuring cylinders are there?
2 measuring cylinders.
How many beakers are there?
2.
2 beakers. In one beaker, what is the chemical inside? In one
Sodium
beaker, sodium
Diluted
hydroxide.
sodium
In the other
hydroxide.
beaker, what is the chemical inside?
Hydrochloric acid.
Hydrochloric acid. Now look at your material. How many milliliter sodium hydroxide you have to take? Look at your tute and tell me. How many milliliter sodium hydroxide you have to take?
50 milliliters.
For that only we have a 50 milliliter measuring cylinder. Understood?
Yes, sir.
How many milliliter hydrochloric acid you want to take?
50.
50. For that only the other measuring cylinder is there. So using the measuring cylinder, you can accurately measure the volume. Understood?
Reactions are exothermic reactions. Heat is always released in such reactions. We are going to measure the temperature rise when dilute hydrochloric acid reacts with dilute sodium hydroxide solution. Measure 25 cubic centimeters of dilute hydrochloric acid into an expanded polystyrene cup.
Now she is measuring the temperature of the acid.
Initial temperature is 28 degrees Celsius.
How many degrees Celsius?
28.
8 degrees Celsius.
Measure 25 cubic centimeters of dilute sodium hydroxide solution. Pour the alkali into the acid.
Now she is stirring, correct?
Yes, sir.
Now both of them are mixed together. What is happening to the temperature? What is happening to the temperature? What has happened to the temperature?
It has increased.
Increased. Now to what value it has come?
3.3.
No, it's now 3 mean 30. You read it as 31, 32, 33, that way you read.
49 degrees Celsius.
39 degrees Celsius.
The temperature rises when an acid is mixed.
Now it is how much?
40 degrees Celsius.
40 degrees
with an
Celsius.
alkali.
So before mixing, what was the temperature?
28 degrees Celsius.
28 degrees Celsius. After mixing, what is the temperature?
40 degrees Celsius.
Maximum 40 degrees Celsius. Then how much the theta value?
12 degrees Celsius.
12 degrees Celsius. So finding the theta. Understood? So this experiment is the one you can see shown to you here. Okay. Are you clear? Can you see the cup? Can you see the thermometer? Can you
Yes, sir.
see a glass rod?
Yes.
Right. Everything what was shown there is here. In this experiment, these two are working as the home reactants. So who are the reactants here?
Sodium hydroxide,
Sodium hydroxide and
hydrochloric.
hydrochloric acid. So mark the reactants first.
Done, sir.
Done. How many beakers are wanted?
2 beakers.
2 beakers. In one beaker, who you will take?
Sodium hydroxide.
Sodium hydroxide solution. In the other beaker,
Hydrochloric acid solution.
you are using a thermometer here, correct?
Yes, sir.
What are the readings you are getting?
28.
No, that is right. That 28 degrees Celsius is temperature of the reactant before mixing, correct?
Yes, sir.
Second one, that 40 temperature of the mixture, correct? Maximum temperature of the mixture. And you can see that white color cup, correct?
Yes.
A rigiform cup. Rigiform cup is good because no any heat loss will be happening. Understood?
Yes, sir.
Right. And there's a glass rod also. Right. What do you measure with the thermometer? What are you measuring? We
Temperature.
measure, okay, measuring initial temperature of acid and what is it? Base. Second, measuring
Measuring
maximum temperature of the what is it? Mixture. According to the video I showed you, initial temperature was how much?
28 degrees.
28 degrees Celsius. Final temperature was how much? 40 degrees Celsius. Are you clear?
Yes.
Right. We use the glass rod to stir the mixture. Why do you use the glass rod?
Stir the mix.
To stir the mixture, you have to well stir, then only they will well react. Understood?
Yes, sir.
The mixture mean who two are together?
Sodium hydroxide and
Solution plus
hydrochloric
hydrochloric acid
solution.
solution. That is the portion we call by the name. What is it? Why do we use a polystyrene cup? To minimize heat loss. Understood?
Yes, sir.
No heat should go out. No heat should go out. If heat goes out, the correct Q value you will not get. So in each and everything can be questioned at you. Understood? So please mark it down.
Done, sir.
Have everyone completed writing it? Adil Hanaf?
No, sir. No, sir. Done, sir.
So, using this whole setup, you can find out only theta, correct?
Yes, sir.
Other than theta, anything you can find out from this? Mean no. But your goal is not finding theta. Your goal is finding whose value? Whose value? The amount of heat coming out. What are you going to find out?
Amount of heat coming.
Is your goal finding the theta?
No, sir.
No.
sir.
If you want to find the Q value, you have to apply the formula. Q is equal to, what is it? Tell me the formula.
Q equals MC theta.
MC theta. This whole unit is helping you to find out only, what is it?
Theta.
Theta. You can find the theta or theta using this experiment. Is it only theta enough to calculate the Q value?
No.
No. Theta is also wanted. M is wanted. C is wanted. Then only can measure the
Heat.
heat, Q, correct?
Yes, sir.
Anyway, one of the component required is theta, correct? Theta how much? Okay, you found 12 degrees Celsius, correct?
Yes, sir.
In that experiment, 12 degrees Celsius. So, theta now known, correct?
Yes, sir.
But another two are there. Who are the two?
Mass
Mn?
and C.
M is mass. Now, to find the mass, we apply this formula. What is the formula we apply?
Mass
Equal density
Mass
into
equals density into
volume.
volume. Right. Now you know how many cubic centimeter hydrochloric acid you took?
50 cubic centimeter.
50 cubic centimeter. How many cubic centimeter sodium hydroxide you took?
50 cubic centimeter.
You mix them together, no?
Yes, sir.
Now how much is its volume? Mixture's volume?
100 cubic centimeter.
100 cubic centimeter. Agree?
Yes, sir.
That means we already know the which part?
Volume.
Volume. Another thing is needed. Then only you can find the mass. What is that component?
Density.
Density. Who do you have to multiply to get the mass?
Density and volume.
Density and volume. In these two, who you know?
Volume.
Volume. Density? Don't know. Actually don't know. So what we do is, we believe or take or assume that density and water's density are same. It is not true, but we believe so. Understood?
Yes, sir.
Yes,
Yes.
sir.
is it true water's density and that mixture's density same?
No, sir.
No. But if you don't take so, you can't find the mass. Understood?
Yes, sir.
And that kind of things are called assumptions. So in determining the mass, what is your assumption? In determining the mass, what is your assumption?
Density.
Yeah. Density and value.
Density of the water is equal to
The solution.
density of the solution. Density of the water is equal to, what is it?
Density of the solution.
Density of the, we believe so. Believing it, what is the density of the water? 1
1000
gram per
kg cubic centimeter.
cubic centimeter. 1 gram per, what is it?
Cubic centimeter.
Cubic centimeter. Then what is the density of the solution?
100 cubic centimeter.
Hmm?
1 to 100.
1 gram per cubic centimeter. 1 gram per cubic centimeter means 1 cubic centimeter's mass is 1 gram. 1 gram per cubic centimeter, what is the meaning? One gram per cubic centimeter, what is the meaning?
1 centimeter cubed is equal to 1 gram.
1 cubic centimeter is equal to
1 gram.
1 gram. Then 100 cubic centimeter equals to
100 grams.
100 gram. Then what is the mass of the solution?
100 gram.
100 grams. Okay, in the O-level paper, they have asked it. What is the assumption you will take? Assumption you will take it is density of the solution is equal to density of the solution is equal to
1 grams per cubic centimeter.
what is it? Density of the solution. Then if you know the volume, if you know the density, you can multiply and get the, what is it? Mass. Are you clear?
Yes, sir.
Right.
Yes.
Now, in the Q is equal to MC theta, did you get to know how to find the M value?
Yes, sir.
Yes. Do from the experiment, from the thermometer readings here, we find the theta, correct?
Yes, sir.
In between, there is a portion. What is it?
C.
Heat capacity.
Specific heat capacity. For that also, we have an assumption. Water specific heat capacity is equal to that solution's
Heat capacity.
specific heat capacity. Don't say heat capacity, specific heat capacity. Understood?
Yes, sir.
Specific heat capacity. Are you clear?
Yes, sir.
Yes, sir.
Right. So what is the assumption in determining specific heat capacity?
Water specific heat capacity.
Water specific heat capacity is equal to
Specific heat capacity of the solution.
of the solution. Third one, theta. In theta, you have to find the maximum temperature. You have to find the initial temperature and subtract. Correct?
Yes, sir.
Here also we have an, what is it? Assumption. Assumption is no heat lost to the environment. What is the assumption in theta determination?
No heat lost.
No
No
to
heat
the
loss to the environment.
environment. Mark it down the assumption.
Done. Sir.
Done, sir.
Done, sir.
Completed?
Yes,
Yes,
sir.
sir.
Right, right. Are you clear regarding this experiment?
Yes, sir.
Right, right,
Yes.
right. So, with this page number 5, with this one, the lesson is over. Okay, page number 5 to page number 8, I have placed questions from the past papers for you to practice. Understood? Understood?
sir.
So it's a small chapter. It's not a big chapter, it's a small chapter. So, inshallah, we will discuss those questions in the coming class. Okay. Thank you. Jazakallah khair. Assalamu alaikum wa rahmatullahi wa barakatuh.